Answers for the types of dilations worksheet from Monday, October 16th. So you should have answers for your first page, both front and back. On page 3, we have number 1 done. We multiplied every number by 2 because our scale factor was 2, and you multiply. So if we had negative 5 times 2 is negative 10, negative 12. So we did all those. Number 2, remember we changed our scale factor, so if you did not change it, you need to change it to 1/2. So if we're doing half of a number, half of 2 is 1, half of 6 is 3. B, half of 8 is 4, half of 4 is 2. For C, half of 6 is 3, half of 6 is 3, and half of 10 is 5. Remember, these two needed to be graphed. I started these are my scale factor points, and these are my original. Number 2, I have not graphed yet, but you should graph it. There are 3 points, so it should be a triangle of some sort. I'm not sure what way the triangle goes. Some sort of triangle. There's 3 points. That means you're making a triangle. 3, 1/5. If you don't have a calculator, you might want to get a calculator. So when we're doing fractions, you can either figure out what is it as a decimal. Find that as 1 divided by 5. So 1/5 is equivalent to 2/10. If your calculator has a fraction key, you might do like -7 times 1/5. If you're using the blue calculator, that's your fraction key. And it gives you 1 2/5. To convert that to a decimal, you would hit the second key and then this button. And it tells you that it's -1.4. Or you could just do -7 times 0.2. Get the same thing. Times 0 is 0. -7 again. So we have -1.4. -5 should give us -1, but let's double check. -5 times 2/10 gives us -1. -2 times 2/10 gives us -4/10, and then our -5 gives us a -1. Number 4, scale factor is 8, so you're multiplying by 8. -1 times 8 is -8. 1 times 8 is 8. 1 times -3 is -24. 8 times -1 is -8. 8 times 1 is 8. 8 times -2 is -16. And 8 times 4 is 32. 8 times 2 is 16. These you should have. This is just a review to make sure you have all the correct answers. Number 5. Scale factor is 4, so we're going to multiply every number by 4. So we get 12 and -20. 0 and -8. -12, -20. And 0, -32. Number 6, 1/8. So let's figure out what is 1/8 as a decimal. 1 divided by 8. 0.125. So we're going to multiply every number by that. So we get, oops, that should be a 7. Okay, I'm just going to go up and then go over here, change my 6 to a 5. Nope. That didn't work. Okay. -5 times 0.125. -625. Okay, 3. You get 375. Remember, there's a decimal. 4 should be half. 3 we already did. We haven't done 7. Negative 7.875. Oh. What is it? Negative 875. Number 7, multiplying by 1.5. Negative 3 times 1.5 is negative 4.5. 4 times 1.5 should be 6. Times 1.5. Negative 12. 1.5. Anything times 1 is itself. Negative 4. We already had a 4. So we're at negative 6. Negative 3. We already had a negative 3. Negative 4.5. Why do the math if we already did it once? And then negative 1 times anything is going to be itself. And negative 5 times 1.5. 7.5. And it's negative. Scale factor is 0.9. 9/10. So we have 5 times 9/10. 4.5. 2 times 9/10. 1 and 8/10. We have 2's again, so the same thing, but these are negative. 4 is negative 3 and 6/10. Negative 6 times 9/10. 5.4. Oops, 4. And last one is a 2, which we already did a bunch of 2's. 1.8 and then 3. Not divide times 9/10. 2.7. So that is this page. Next, we have our books, which you should have your book open up to lesson 6. If we go to lesson 6, that's 3. Lesson 6, similarity. We have talked about similar triangles already. Similarity 6.1, equivalent expressions. Equivalent means they will end up equaling the same thing. They might be written differently. First, we need to figure out what is our answer here so we can make an equivalent one. We need 3 of them. 1, 2, 3. Let's figure out what does this equal. Well, when I combine inside my parentheses, because that's what we have to do first, I get 5 times 10 minus, and then if I do 8 times 3, not 8.3, 8 times 3. These two would be equivalent, so I can actually write this one here. 10, 5 minus 8 times 3. Okay, now let's solve a little bit more. Let's solve this part. 8 times 3 is 24. So I have 10, 5 minus 24. All I did was solve this portion of it. Let's go a little bit a step farther. Let's solve this. 10 times 5. Well, that's 50 minus 24. All of these are equivalent expressions. They're all the same expression. Just each time I solved a step towards getting to the answer. And then our final answer would be 26. If we do 50 minus 24. So when you want to find something equivalent to it, you can just solve piece by piece by piece, and it gives you equivalent. Next, triangle EFG. Triangle EFG. So this one, EGH. this one right here, is similar to LME. Find a sequence of translations, rotations, reflections, and dilations that show this. Well, we can move triangle EGH down. So translate EGH so that E maps to L. Remember, maps means they overlap. So now we're here. So our triangle, let me get another color, is right here. And I know that's the triangle because this one has a width of 4 across, and then I just made it so it's 4 across. Then dilate EGH with a scale factor of, and am I going to get bigger or smaller? Well, to go from this big one to the small one, I'm going to get smaller. We have to figure out how much smaller. Remember, to find your scale factor, it is your copy over original. Well, my copy length is 2. My original length was 4. And I can reduce that to 1/2. So my scale factor is 2/4, or 1/2. This one is half the size of my original. All right, hexagon ABCD and hexagon HGLKJI are similar. Find a sequence of translations, rotations, reflections, and dilations to show this. Okay, this one, you will need a piece of patty paper. If you don't have one, get one from the front corner of my desk so that you have one. So if I first, they're facing opposite ways. It's flipped, so we need to reflect. So reflect A, B, C, D, E, F, so that A maps to H. To H. Okay, and then we need to figure out how many times bigger is this one than this one. Then dilate A, B, C, D, E, F with a scale factor of, okay, let's draw this out. We don't even have to draw the whole thing out. We have to know how long this is. So when I, let's see, so A originally only went to here. So there's 1, 2, 3. So there are 3 lengths of A in here. Oops. With a scale factor of 3, because it's going to get 3 times bigger to go to here. And we can double check our measurements with the length of it. Well, from A to F, it's that long. So we got 1, 2, 3. So it's 3 that way as well. We could say this is a length of 1 and this is a length of 3. And our copy would be 3. Our original would be 1. Well, if we reduce that, we get a scale factor of 3. Next. Sketch similar figure similar to A that only uses the transformations listed to show similarity. Okay, I'm going to get a pencil out. So this one you do need to trace. Oh, whoops. And we're tracing the best that you can. Okay, so here we go. So number 1 says translate a translation and a reflection. Sketch it B. So I'm going to translate down and then reflect over. Do you think it's going to make lines on there for me? It did. You can barely see them, but there's marks there. Is that where it went? Too far. Okay, so I'm right here. Okay, and this is B. On the next page, it tells you more directions. So you can't see it, but you can see this. Okay, a reflection and a dilation with a scale factor greater than 1. Label that C. Okay, so a reflection. I'm going to reflect over this line. And a scale factor greater than 1. So originally I'm right here. So I can do 1.5. So let's do 1.5. So this is half the length. That's where my first dot was. Half its length is right here. Okay, so let's connect all this. So originally this is 1 length. This would be half of it. So I'm going to go to the top and put a dot there. Okay, let's go to the top of this one. Okay, so if this is half, so I need to go up here. Sweet, the dot's there. Half of it's right here. Okay, now we need to figure out this. So originally it's right here. So there's 1 of it, and then we need half, which is right here. So I'm going to make this dot go over to that dot. And then half the height up. Man, my light just turned off. Okay, so there's 1 height up, and then half of it is right here. Sweet. All my dots showed up. It's a little crooked. So this is C, and our scale factor was 1 greater than 1. It was 1.5 because we did a full one and then half of 1. Okay, so number 3 over on the other side says a rotation and a reflection. Label it figure D. Okay, so let's see. A rotation. Okay, so I did it from the top point. And a reflection. I'm going to reflect it this way. And a reflection over that same point. So my image is here. And this is figure D. And the last one, a dilation with a scale factor less than 1 and a translation. I will come back to this. So let's see, a dilation and a scale factor less than 1. So if we're doing a scale factor of less than 1, so maybe half the size. So that's the new top. This new side. It's only this tall. Half of this distance is here. So here's my new shape. Dilated to a half. And then maybe I'm just going to translate it down. So I go here, here, and here, and here. So crossed. And I can't see where the other one is. We'll end it right there. And labeled this one E. So you should have all of this in your book. 6.4, your teacher will give you a set of 5 cards and your partner a different set of 5 cards. Use only the cards you were given to find at least one way to show triangle ABC and triangle DEF are similar. we're not going to have cards. We're only looking at this. So if we're looking at these two shapes, these are similar. We have point P. My guess is that's our center of dilation, or center of everything. I'm going to connect my line through all these points. And then B. That's a little off. If you used a ruler, you should be dead on between the two. So you can say translate A to D. So one method might be translate A to D. So now our triangle is here. And then dilate center D, scale factor. So this is one length. 1, 2, 3, 4. 1, 2, 3, 4. So there's 2. 1, 2, 3, 4. Is 3 because it's 3 times bigger. Another way, you could have said dilate A, B, C with center P and a scale factor of, so originally A, P and A are 1, 2, 3, 4 units apart. 2, 3, 4. 1, 2, 3, 4. So it's 1, 2, 3 times the distance. Which is good that these are the same, because it needs to get 3 times bigger or 3 times farther from P. You could have said translate B to E and dilate using center of E to 3 times bigger. Any one of those would have worked. So there are many different methods you could use. We do need to have at least 2 written down. If you come up with a third one, write your third one down. All right, that brings you to your summary. So similar means your shape may have gotten bigger or smaller, and it may be even in a different location. However, if your shapes are similar, your angles remain congruent. So whatever this angle is, when this shape right here looks like it's reflected and rotated, our congruent or corresponding angles are B and E. They should have the same measure of angle. Line BC, if it's multiplied by 2, it's going to make EF. My guess is 2. It might not be 2. On to our homework. Each diagram has a pair of figures, one larger than the other. For each pair, show that 2 figures are similar by identifying sequence of translations, reflections, rotations, reflections, and dilations that take you from the small figure to the large figure. So we're always going from small to big for this problem. Small to big. So this one, we are going to translate A to C. A to C. Then dilate with center C, scale factor of, well, originally this is ABC right here, after we translated it. So originally C is only 1 unit, and CF is 2, so our scale factor is going to be 2. It gets 2 times bigger. This shape is rotated we aren't going to know degrees, but we can say so that D point maps to D prime. B, C, D, so that D maps to D, and it's listed as double prime. And then, so that's one, dilate around D double prime with scale factor. So it's here. Pretty sure it's a scale factor of 2. Because when I lined up this side with this one, it's 2 times bigger. It's 2 of the bottoms. Number 2. Here are 2 similar polygons. Measure the side lengths and angles of each polygon. What do you notice? Angles are going to be hard. We don't have a compass, however, or a protractor. We have patty paper. So you can trace your shape. And then you can compare angles of the 2 shapes. You compare side lengths, you can measure them, and you can compare side lengths. So, what do you know side lengths? Side lengths and angles. Number 3, each figure shows a pair of similar triangles, a small one and a big one, a small one and a big one contained in the other. So it's inside the other one. Describe a point and a scale factor used for a dilation moving the large triangle to the small one. So remember, when we're going big to small, your scale factor is less than 1. So it's going to be a fraction or a decimal. How many times smaller does this one get? After you finish this, make sure you rip out page 37, 38, this one right here, and turn it in with your name on it. Also, if you have not turned in your minutes 1 through 20, make sure you get those turned in as well.